In this video, I want to show how to solve logarithmic equations. And there are two methods that we'll need to use depending on how the equation's set up. The first case I'm going to look at, log base a of x equal to log base a of y. And so we're taking the log of the same base on both sides. And in this case, we can just set x equal to y and then solve. However, there is a very important extra step for logarithmic equations. We absolutely have to check your solutions. Logarithmic equations can result in extraneous answers, things that show up as solutions but are not actually solutions. In particular, what we're looking for is things of the form log base a of x where x is less than 0. This is not possible. We can only take the logarithm of a positive number. So if we stick in our solution and we get the log of a negative number or the log of 0, that tells me that this is actually not a real solution. Let's start with the equation log base 5 of 3x plus 8 equal to log base 5 of 10. So in this case, we have a log on both sides, and they have the same base. So we can just do 3x plus 8 equal to 10. Subtract 8 from both sides. That gives us 3x equal to 2. Divide by 3. And I get x is equal to 2/3. Plugging that in, 3 times 2/3 is 2. So this is 2 plus 8 is 10. So yes, this is an actual solution. I do not get the logarithm of a negative number. Next, let's look at this equation, log of x plus 2 plus log of x minus 2 equal to log of 3x. In this case, I have 3 logarithms. So it's not quite of the correct form, but we can make it of the correct form. One of our properties of logs say that if we take the log of something plus the log of something else, then that's the same thing as log of the first times the second, so log of x plus 2, x minus 2. Equal to log of 3x. So now this says log of x squared minus 4 is equal to log of 3x. So now we do have a logarithm on both sides that's of the same base. So x squared minus 4 is equal to 3x. Since it's a quadratic, we want to get everything on the same side. X squared minus 3x minus 4 equal to 0. This factors into x minus 4, x plus 1 equal to 0. So that gives us two solutions, x equal to 4 and x equal to negative 1. And we do need to check. If I stick in 4, this would be log of 4 plus 2, log of 6, that's okay. Log of 4 minus 2, log of 2, that's okay. Log of 3 times 4, log of 12. That's okay, so this is a solution. If I plug in negative 1, log of negative 1 plus 2. Negative 1 plus 2 is 1. I can take the logarithm of 1. Here, if I plug in negative 1, I have the logarithm of negative 1 minus 2, or log of negative 3. And that's bad. I cannot take the logarithm of a negative number. So my only solution is x equal to 4. Here's the property of logarithms that I used in the previous example. Log of m plus log of n is equal to log of mn. The other one that we may need to use in these is log of m minus log of n is equal to log of m over n. So these are really two important properties of logarithms that we use a lot in solving these types of equations. Now let's look at log of x plus 4 minus log of x plus 1 equal to log of x. The properties we just discussed said log of m minus log of n is equal to log of m over n. So the fact that we have a subtraction here tells me I can rewrite this as log of the first over the second is equal to log of x. We then set appropriate parts equal. Since we're taking a log on both sides, we have x plus 4 over x plus 1 equal to x. To solve this, I'm going to multiply both sides by x plus 1. On this side, the x plus 1's cancel. I'm left with x plus 4. On this side, we have x times x, and then x times 1. With a quadratic, we need to get everything on one side, so I'm going to subtract x and subtract 4. That gives me 0 is equal to x squared minus 4. Factoring gives me x plus 2, x minus 2. So my two possible solutions are -2 and 2. So let's double check. If I stick in -2, -2 plus 4 is 2, so this is log of 2. That's okay. -2 plus 1 is -1. Log of -1, that's not allowed, so this is not a solution. If we look at x equal to 2, 2 plus 4 is 6. Log of 6 is allowed. 2 plus 1 is log of 3. That's okay. And then here would be log of 2. So I only have one solution here, which is x equal to 2. The next type of logarithmic equation is something of this form here, where we have a logarithm, but it's equal to just an individual number instead of a log. The first step will be to actually write it in this appropriate form. One side should have a single logarithm, the other side should be just a number. The second step, we then convert to exponential. We have a to the y power is equal to x. We then solve the appropriate equation. And once again, we need to check the solution. So if we look at this equation, it's already written in the appropriate form, and we need to move to exponential. So here's our base, 3. We raise it to the second power, and it should be equal to 2x minus 1. 3 squared is 9, is equal to 2x minus 1. I can add 1 to both sides. 9 plus 1 is 10, equal to 2x. Dividing both sides by 2 gives me 5 is equal to x. And we can double check our solution. 2 times 5 is 10, minus 1 is 9, and so that is a valid solution. X equal to 5. For my next example, I have log base 4 of x plus log base 4 of x minus 12 equal to 3. So we need to start by condensing this left-hand side, and the addition tells me I can multiply. Log base 4 of x times x minus 12 is equal to 3. We can then convert to our exponential. 4 to the third power is equal to xx minus 12. 4 to the third power is 64. On the right-hand side, I have x squared minus 12x once I distribute. With a quadratic, I want to get everything on one side, so we have 0 is equal to x squared minus 12x minus 64. We need to factor. So I need two numbers that multiply to be negative 64 and add to be negative 12. And we can get that with negative 16 and positive 4. So my solutions end up being x equal to 16 and x equal to negative 4. If I double check 16, log base 4 of 16, that's fine. 16 minus 12 is 4. Log base 4 of 4, that's fine, equal to 3. So this one works. If I plug in negative 4, I get log base 4 of negative 4. I cannot take the logarithm of a negative number, so that one's wrong. And my only solution is x equal to 16. Let's do one more. This time we have log base 9 of x plus 6 minus log base 9 of x equal to 2. We need to condense the left-hand side, and this time we're subtracting. So we take log base 9 of the first over the second. And then we can convert. We have 9 squared is equal to x plus 6 over x. So 81 is equal to x plus 6 over x. We need to multiply both sides by the denominator. That gives me 81x on the left-hand side. The right-hand side becomes x plus 6. We can then get all of the x's together, so I subtract x from both sides. That gives me 80x is equal to 6. And then dividing by 80, we get x is equal to 6 over 80 or 3 over 40. And we can double check. 3 over 40 plus 6 is going to be a positive number, so that's fine. 3 over 40 is positive, so that's fine. So this would be our final solution.